So in lesson 1.3a, since we're done with 1.2 as of last week, we're talking about prime factorization. If you follow science of the human body, you know that we all have a unique genetic DNA code. We all have our own unique fingerprint. There are no people with the exact same code in the world. So again, those things are kind of crazy. Numbers are similar, but there is no DNA for a value. So instead, what we look at is a process called prime factorization. Prime factorization is a process of breaking a number down to its prime factors. So prime factors are just numbers that can only be divided by itself in 1. So looking at these numbers here, I cannot divide 3 by anything except for 1 and 3, because 1 times 3 is the only combination that makes 3. I can't do anything with 11. The only thing that multiplies to make 11 is 1 times 11. And I want you to notice how I'm kind of putting these numbers down off to the side, but eventually what I'll do is I'll attach like a little tree to them. But you can't do anything with 11, but 1 times 11. 7, same thing. 1 times 7. There's no 2, 3, 4, 5, 6. They don't go in. 19, also another what you would call weird number, is a prime number. The only thing you can do is 1 times 19. And 31, same thing. There's nothing you can divide in 31. It's just 1 times 31. Each of those values, again, cannot be divided by anything besides itself, which would be 3 and 1. 11, because you're talking about 11 and 1. 7 can be divided by 7. 19 can be divided by 19. Another phrase you don't really need is composite numbers. Those are numbers that are not prime. Those can be divided by more than itself in 1. And so if you look at 8, for example, we can do 2 times 4. And again, notice how I'm using the tree form. So I'm actually attaching those using a tree, and that's kind of what you want to be doing today when you start working on that. 6, we can do 2 times 3. For 9, we can do 3 times 3. For 15, we just did this last week, 5 times 3. And the numbers don't need to be in any specific order. Just make sure you understand, again, how to break them down. 33 is an 11, so 11 times 3 would be what you would use. So because neither of those numbers is 1, these are not prime because they can be broken down further, so to speak. So again, prime factorization means break the number down until nothing else but a number that can be divided by itself and 1 is left. Our job in this lesson is to break down whatever number we're given until all of our remaining numbers are prime. We'll put the numbers in the order afterwards. Look at the following example. So if you want to write this down for yourself, you can on the back of your bell ringer sheet. There will be some stuff that you're going to have to do later on. So if you want to have like a note to not have to rewind the video later on, that works too. When I look at 50, you got to start thinking, now what do I know that can go into 50? Well, here's the thing. It's an even number. Any even number can be divided by 2. Some of you might see 5 times 10. Doesn't matter which way you go. I'm going to say 2 times, let's see, if I cut 50 in half, I believe 2 quarters makes 50, so 2 times 25. 25, I mean 2 is prime, because again I can't do anything with that, so I'm going to leave that where it is, but 25 can be broken down to 5 times 5. And so that's prime, that's prime, that's prime, which means now I put them in order. So prime factorization would be 2 times 5 times 5. Now let's say, for example, you wanted to go 5 times 10. Remember I talked about the genetic code, how it always ends up the same. 5 times 10 could be your first start. 5 is prime. 10 is 2 times 5. Both of those are prime. So if you put it in order, you end up with 2 times 5 times 5. That is what we would call the genetic code of 50. So the prime factorization is just looking at a number and being able to break it down to prime numbers as far as possible. Pretty much the game is, if the number you have can still be broken down further, keep breaking them down until you can't. The prime numbers themselves are first few prime numbers are 2, 3, 5, 7, and 11. 4 is not prime, 6 is not prime, 8, 9, 10 is not prime, and so on. But when you end up with these numbers, you're pretty much at a stopping point. 60, again, you don't need to do both of these, you only need to do one. 60 again is an even number. Once you see an even number, it means I can divide it in half, or cut it in half, which means I can divide it by 2. 2 times what makes 6 would be 3, and then just bring your 0, so it has to be 2 times 30. 30 can also be cut in half. So that'll be 2 times, or you could even do 3 times 10 if you see it, 3 times 10, because anything ends with a 0 can be divided by 10. But either way, 30 can be cut in half to be 2 times 15. Prime and prime, but that is not prime because 15, as we talked about earlier, is 3 times 5, which means this number, because all those are prime now, would be 2 times 2 times 3 times 5. That's it. All right, that is prime factorization. And then 100, again, 2 times 50. Oh, from there we can go 25 times 2. Again, doesn't matter what order, just think of a number that can be used to break it down and you're good. 25 is 5 times 5. And then from there, pick everything that's on the bottom. So we have 2 2s and 2 5s. And you'll notice that none of these answers are the same because every single number has its own code that it lives with, the prime factorization part. So that is the process that we're doing today. I'll be looking at your notes for this video today for credit, so please turn your bell ringer over to work out a couple of problems. That way you can get feedback on your mistakes as you're working. Break down each number into prime factors. If you need to rewind the video to look at the examples again, please feel free to do so. The overall point is to see what you've picked up from the video. So when I show you these numbers here, if you need to rewind to see what I did, that's fine. Use notes, use whatever, but just make sure you're practicing. And again, don't forget to answer the question that pops up at the very end so you get video credit as well. Again, choosing not to do so will result in a 0 for the video. So answer those questions there, and once you do, make sure your name's on your notes, hand them in, and that's it. Good luck today.